Hey everybody. So this is the second step of cellular respiration. This is step 2 of 3. As mentioned previously, the step before this was glycolysis, a process that happened outside of the mitochondria in the cytosol of the cell where there is no oxygen. Now we are in the mitochondria where we do have oxygen. So we are going to start to see a complete oxidation of glucose, which is where we're going to see the breaking of the pyruvate into carbon dioxide. This is going to create it's going to extract a little bit of energy from the food, but once again, it's going to be very similar to glycolysis in that we're going to gain a little bit of ATP, but also some electron carriers that we can use in the final step, which is going to produce a lot of ATP. That said, should have said this first. Krebs cycle is also known as the citric acid cycle. So if you ever hear that, it's the same thing. Back to the process. Most of the chemical energy originally stored in glucose is still inside the two pyruvate molecules. So this is where we're going to see further oxidation, as mentioned. All right. So in the presence of oxygen, the oxygen is going to enter the mitochondria and it's going to be oxidized so that it can grab some of those carbons from off of the pyruvate and create CO2 and be released from the body. This is why we exhale CO2. Within this process, we're going to see an oxidize from acetyl-CoA into CO2, as mentioned. Energy is going to be released. This is going to be an exergonic process. And we're also going to see a reduction in coenzymes NAD plus and FAD, which is going to make NADH and FADH. All right. So with that said, those are going to be the coenzymes that we're going to see later on, the electron carriers that we're going to see later on in the electron transport chain at the end. So the Krebs cycle has 8 enzymes in very specific controlled steps. I'm not going to go in those in significant detail, but what I will show you is an image that does a good job demonstrating what's going on in this process. Again, I'm not going to make you responsible for every single enzyme and every single little detail, but I can show you what's happening. If you look here at the top, we start off with the pyruvic acid, the pyruvate. It is going to lose one of its carbons. That carbon is going to bond with oxygen, the stuff we inhaled, right? Hence the reason why it's so important we're in the mitochondria, because that's where the oxygen is. From here, we're going to get acetic acid, right? So it's only 2 carbons. This acetic acid is then going to turn into citric acid, right? So what we're going to see is these 2 carbons are going to bond to this 6 carbon molecule and go through a cycle here. From here, we're going to start to see a few things happen. Number one, we're going to make some NADH using, we're going to make NADH2 using NADH. And then from here, it's going to continue on. We're going to create ATP. And then it's going to continue over here. We're going to make some FADH2. And then it's going to continue all the way back up to the top. And we're going to be able to re-establish the same connection again, right? This is a cycle. All right, so we can continue to do this over and over. So is it just the 2 pyruvates that are being used? No, we can continue this with additional pyruvates. So this cycle is going to continue and continue over and over again. Each time it's going to produce NADH2. It is going to create FADH, and it is going to create ATPs, all of which will be used in the final step, the electron transport chain, which will be in our next video. So once again, please take a minute, look at this, and just make sure you're feeling comfortable with what's going on in the citric acid cycle, also known as the Krebs cycle.